Hey everyone, this is for 11/16 Monday if you missed class. So we're going to go over a few things. I have some things to show you. All right, so we're going to get started. So you should have this document open. All right, and we're going to go through each of the numbers, talk about properties of metals and nonmetals. Okay, so how do we classify elements? Last week we talked about classifying substances as pure substances or mixtures and what that is. So when we look at the periodic table, how do we determine what the elements are? So we have a section that's nonmetals, okay? And this is in orange on this one. Notice hydrogen over here is technically a nonmetal, even though it's over here. We have this thing we call a staircase, okay? This purple section are metalloids or semi-metals. And all the green ones, most of the periodic table, are metals. So what makes something a metal versus a nonmetal? So when things are malleable, they're easily shaped. So our definition, so in number one, our definition for malleable is easily shaped. So pause and write that down. Then we're going to circle the term that makes the following sentences correct. So in notability, you're going to circle malleable or not. So metals are malleable or not metal? Well, let's take a look. I've got here a spoon. It's made out of some metals, and you can definitely shape and bend that. It does not snap. It doesn't shatter. It is malleable. It's easily shaped. Okay, sometimes you have to heat things up to make them malleable. Metals a lot of times, but metals are malleable. This right here is a stick from outside. This comes from a tree. This is made of carbon. Okay, carbon, right? Carbon is over here. Everything to the right of these green circles is a nonmetal, so carbon's a nonmetal. Most of trees are made out of carbon. It's different than the spoon, right? It is, when you bend it like that, it doesn't just go back to its shape. In fact, it breaks, right? It is not malleable. So nonmetals, not malleable. So which substance out of these two is the metal? You're going to write that down in 1C. Pause if you need to. Number two, we are going back to here. So number two, metals are ductile. It's a funny word. That means they can be stretched or made into a wire. So here is a coil of metal wire. It means when you pull on both sides, right, not with your hands, but with a machine, you can draw it out and you can make it into a wire, and it doesn't tear, it doesn't break. So this definition, you're writing down in 2A on here, define ductile. So if you need to pause it here to write that down, please do that and replay when you're done. Okay, we're going to see a little example. What's happening on the molecule level when something is being drawn into a wire. Okay, so here's our molecules. If you pull from both ends, they stretch. They do not break. They're still next to each other, near each other, and they will make a wire. Okay? All right, so that's number two, ductile. Okay, so you're going to make the following sentences correct. Metals, this metal is made into a wire, which means it is ductile. Nonmetals, you try to make this into a wire, pull on it, yeah, not going to work. Okay, so nonmetals are not ductile. So is the wire, I already told you this, is the wire a metal or non-metal? Just to clarify, right? What you think. Okay, number three is about being lustrous. Okay, luster is how light interacts with the surface of a substance. It generally describes an object's radiance or brilliance. What we say is, how shiny is it? So if it's really shiny, it is high luster. Okay, if it's very shiny, it has high luster. So pause here, and you're going to write this definition down on 3A. So 3A, right here, you are writing this definition. Pause and play when you're ready with that definition. Okay, so you have the definition down in A. We're taking a look at the spoon. This is made out of metal. We already said that. right? So you can see the light from the window right there reflecting off the surface of this. Okay, that means it is lustrous. Nonmetals, we see any light reflecting off our carbon, our stick? We cannot. It is not lustrous. Someone in class brought up, what about if the spoon got rusty, if there was rust on it, it wouldn't be shiny anymore? And we talked about how that is because it's reacting with the air and water around it, right? So on the surface of the metal, you get this coating of something that isn't metal anymore. It's not just metal, it's a metal oxide. And our oxygen from the air interacts with the metal and makes a new substance. And that new substance has some non-metal in it, some oxygen. Oxygen is in that corner, it's a non-metal, right? So that's why rusty things aren't shiny anymore. Okay. All right. Number 4. Okay. Things that expand and contract. Okay, so all substances, metal or non-metal, expand and contract when they are heated or cooled. Okay, so everything does this. Expand, you're writing this definition down in 4A, is to grow larger. Contract is to grow smaller. Okay, that's a little counterintuitive. It sounds weird. You can say get smaller if you want. The difference between a metal and a non-metal is that non-metals are brittle. They break when they get heated and cooled a lot. So this is a picture of a sidewalk. Okay, it has cracks in it, right? Over winters and summers getting warm and hot, it's gonna form cracks in it, and that's made of non-metal. They're brittle, they're gonna break. Metals, on the other hand, expand and contract, but they do not break. So we're gonna watch a little video. Okay. Here. So the metal ball can go through the ring right now, but now scientist is going to heat it up for 3 minutes and get really, really hot. You can see the chain is going to start getting red after a while, so heat it strongly for 3 minutes. And then you take some tongs, because otherwise you burn your hand. It does not fit through the ring anymore. It expanded. It doesn't fit through the ring anymore. Did it break? Did it smash into pieces? Nope, it just expanded. Now we're going to cool it down under some water. Good. When it's cooled all the way back down to its room temperature, it fits back through the ring. Okay. So that shows us that our metal, right, our metal expanded and contracted without breaking. That's true. Non-metals, however, they break. When they expand and contract a lot, they are breaking. So this one is false. All right, moving on to number 5. We're talking about conductivity. This is electrical conductivity, so what conducts electricity, or we can talk about what conducts heat. And conductivity, here's our definition, is a charge, electrons, electricity, or energy, heat, can pass through. Charge or energy can pass through. So pause this and write that definition down if you need to. Okay, so you should have this definition in 5A. Okay, conductivity. And then we have some answers for B. Metals are conductive. Non-metals are not conductive. Okay, so metals conduct electricity. Non-metals do not conduct electricity. Oop, there's an error, that R shouldn't be there. Okay, so we're going to watch a video, a little experiment where you set up a circuit with some wires and a light bulb. So if this light bulb lights up in the circuit, that means the electrons are able to flow through, the electricity is able to flow through. If they do not, that means it is not conductive, they're not able to flow through.
Make an electric circuit with the help of electric wires, battery and the bulb. Connect the iron rod between the open ends of the wires.
This is an iron rod. And when all the wires connect, And the battery
What do you see?
The
You
light
can
shines.
see that the bulb glows. It means that iron rod is a good conductor of electricity. Now,
Okay, iron, just to clarify, iron is right here. It's in the metal section, so that is conducting electricity.
connect the coal piece between the open ends.
This is a piece of coal, which is carbon. Okay, carbon's over here. Something right of the stairs, so it's a nonmetal. What do you think is going to happen? Is the light bulb going to light up or not?
Of wires. You will observe that the bulb does not glow this time. It shows that coal is a bad conductor of electricity. On repeating the same activity with copper wire, you will see that the bulb glows.
So copper wire, copper's over here. Number 29, it's left to the left of the stairs. Here's the stairs. It's a metal, so it's conducting electricity.
On the other hand, when the piece of plastic is connected between the open ends of wire, the bulb does not glow.
So plastic isn't just an element on its own, but it's made up of nonmetals. Okay, so it does not conduct electricity. So that proves our answer for B. Okay. So in this one it says, hold the can by the lid, and when you flick the metal bottom, it lasts a while. You hear a ringing sound. Okay. So it's like a bell. Okay, metals are sonorous. Sonorous means they create a clear bell-like sound when struck. So pause this and go to 6A, and you can write down the definition in 6A and play when you're done. Okay, so metals are sonorous. So 6B. Oh my goodness, 6B, metals are sonorous. Non-metals are not sonorous. This is a piece of wood. It's made out of the same stuff as the stick, which is a lot of carbon. It's not making a sonorous, it's not sonorous. It doesn't have a ring that happens. Okay, so non-metals are not sonorous. Okay, 7 through 11, we're just going to go through on the PowerPoint. We don't have demos, unfortunately. We have some pictures. If we were in the lab, we would be doing all these things. Okay, 7, do metals or nonmetals react with acids? Okay, so it says right here, metals react with acids. In this test tube, we've got a liquid acid, and there's a piece of metal in there. You see some bubbles. That means we've formed a gas. It is reacting. So number 7, metals react with acids. Number 8, metals react with salts. Okay, salts could be like table salt, NaCl, or some different things, right? Bath salts are magnesium sulfate, road salt is calcium chloride. Those are all salts. When you put a metal piece into a salt, you're gonna get some reaction happening. So this is zinc and copper sulfate, and eventually you get all this solid forming, this copper solid forming on the outside. So that is reacting with the metal. So number 8, metals react with salts. All right, number 9, melting and boiling point. All substances have a melting point, all right? Like water, we boil it on the stove. We know it boils at 212 degrees Fahrenheit or 100 degrees Celsius, but other things have different melting points. For example, this metal spoon, you would have to heat it up a lot to get it to melt into a liquid, right? So metals have very high melting and boiling points. Non-metals have very low melting and boiling points. You can tell that's true. So if we look at a lot of these non-metals, these are all gases at room temperature, okay? Meaning they've already gone from a solid to a liquid to a gas by the time we get to our just normal room temperature. So oxygen, for example, it's a gas. You could cool it way, 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 way down. You can freeze and get oxygen to go back and condense to a liquid. All right, liquid nitrogen you've heard of, maybe seen some demos in science class. Okay, So in general, do elemental metals or nonmetals have higher melting and boiling points? Yes, metals have higher melting and boiling points in general. It's not always true, but in general, metals have higher melting and boiling points. Nonmetals have lower. What is true, number 10, what is true about the density of metals? Now remember, density is how closely packed things are, how much mass per amount of space they take up. So metals are heavy for their size. So metals are dense, they have a high density, right? Their molecules are packed really closely together. Right, and number 11 is important here. What is a metalloid, or some people call it a semi-metal? They are just like the in-between ones. Okay, so it's our staircase right here. All these green circled ones. There's not that many. 1, 2, 4, 5, 6, 7. 7 of them. Okay, and they have properties of a metal and some properties of nonmetals, and in the same element. Arsenic is lustrous, it's shiny, but it is very breakable, it's brittle. So luster, having a high luster is like a metal, but being brittle is like a nonmetal. Okay, germanium, super shiny, lustrous, that's like a metal, but it does not conduct electricity or heat. That is like a nonmetal. And silicone is brittle, it breaks really easily like a nonmetal, but it does conduct a little bit. Okay, so that is the end. That's number 11. So you're going to turn this into Schoology when it is all filled in. You can go back and get any definitions that you need in the video. I will see you all on Wednesday.